What is pump cavitation? The pump cavitation can be defined as it is the formation of a vapor bubble within the pump, otherwise cavities in the fluid around an impeller at low pressure. When the bubbles in the pump are collapsed, then activate strong shockwaves within the pump, which results in major injury to the impeller of the pump. There are many reasons for causes of pump cavitations, which include impeller failure, extreme vibration, and decrease of the flow, superior to required power utilization, increase in temperature, and increase in liquid velocity, unwanted liquid flow conditions caused by obstacles, and reduced flow or force. Types of pump cavitation. There are two types of pump cavitations, namely suction cavitation and discharge cavitation. Number 1. Suction cavitation. The suction cavitation occurs when a pump is below low pressure, otherwise high vacuum conditions. When the pump does not receive sufficient liquid flow, then cavities, otherwise bubbles, will form at the impeller's eye. When the bubbles take over to the expulsion face of the pump, then the condition of fluid will change, reducing the bubble in the direction of fluid and cause it to collapse adjacent to the impeller face. Number 2. Discharge cavitation. The discharge cavitation occurs when the expulsion force of a pump is very high. As the expulsion pressure is high, the flow of fluid will difficult to flow out from the pump. Thus it flows within the pump among the impeller as well as the housing at extremely high velocity, that will cause a vacuum on the housing divider and the formation of the bubble. Signs of cavitation in pumps. If the pump is cavitating, it will typically vibrate, deliver less flow, and make a noise that sounds like marbles going through the pump. The sound may start out at a low level and increase in intensity over time as material is chipped away and the surface of the parts becomes rougher. Other signs of cavitations are reduced flow, otherwise force, failure of bearing or seal, unpredictable power use, the gradual destruction of an impeller, sudden vibrations. What are the typical causes of pump cavitation? The cause of cavitation in pumps is usually due to insufficient NPSH, net positive suction head, energy on the suction side of the pump. Net positive suction head is the energy required to push the liquid into the pump. This can be caused by having the pump at too high of a distance above the fluid source, having too small of a diameter of suction pipe, having too long of a distance of suction pipe, having too many fittings on the suction pipe, handling a liquid with a low vapor pressure, running the pump too fast. The end result of cavitation is the collapse of the vapor bubbles inside the pump, which can cause several problems. The first problem is a reduction in the pumping capacity of the pump. If the pump is unable to keep up with the incoming flow, then an overflow situation may occur. Cavitation also causes damage to the pump. How to prevent cavitations? The available net positive suction head of the system must be equal to or greater than the net positive suction head required in order to avoid pump cavitation difficulties. In most cases, cavitation may either be avoided or corrected by any one or combination of the following practices. Keep available the net positive suction head as high as possible by keeping the maximum available suction head on the impeller eye, keeping the liquid temperature as low as possible, keeping the suction pipe size as large as economics will allow, avoiding any unnecessary elbows or other fittings and valves on the suction line to keep suction line losses as low as possible, selecting the pump which gives the most favorable NPSH requirements within the bounds of economy, specifying the pump discharge head as near as possible to actual operating conditions. The most common cause of cavitation in pump installations is pump discharge requirements specified for above the actual requirements of the installation. From the performance curve data, it's obvious that the tendency toward cavitation increases as the pump head drops or as the capacity increases.